All right, chapter 5, LT1. I fixed it, so I got to re-record the video. Here we go. I can factor using greatest common factor and the difference of perfect squares. Our calendar is no longer correct, so we're moving on. So remember, factor is a verb to rewrite a quantity as equivalent product, but you can also talk about factor as being a noun as an individual component of a product. So like 2 times 3, both 2 and 3 are a factor of 6. You know what I'm saying? Okay. Greatest common factor, how we factor greatest common factor is you look at your terms. It could be as many terms as there is, and see if there's something you can take out of every single term. So for example, 3x squared plus 6x. Well, I can take out a 3x. The greatest common factor between those two terms is 3x. So now all I have to do is divide both those terms by 3x, and what's left is in the binomial. Sorry, 3x squared divided by 3x gets me x. 6x divided by 3x gets me 2. That is factored. Okay, we're factoring it into its pieces. We took out the GCF and we divided, and now what's left is in the binomial. 20x minus 5x squared, we can take out a 5x. Dividing both those terms by 5x is going to give me 4 minus x. Do not turn the order around. Factor as it is. And that's greatest common factor. Okay, they can get bigger and bigger. There could just be numbers. There could be terms. Here we go. 14x cubed plus 28x plus 35. We can take out a 7. Dividing each of those terms by 7 yields 2x cubed. Set 28x divided by 7 is 4x. 35 divided by 7 is 5. Final answer. Okay. Pause the video if you need to pause it to write it down. Here we go. 10a to the 6th, 80a to the 4th, 100a to the 3rd, 70a. So numbers, I can take out a 10. Letters, variables, a to the 6th, a to the 4th, a to the 3rd, a to the 1st. You can only take out the least amount that they all have in common. So that would just be 1, a to the 1st. Dividing each of those terms by 10a would give me, the first term would be a to the 5th. Second term would be 8a cubed. Third term would be 10a squared. Last term would be 7. Final answer, factor. You can always check yourself by distributing it back in. Okay, sometimes there's multiple variables. Like I said, I like to do my numbers first. So 70, 35, and 28 and take out a 7. X's, I have x here, x squared, x. So they all have an x, so I can take that out. Y's, y to the 10th, y. I can take the y's out as well. So 7xy would be my GCF. Dividing that out of there, we would end up with 10y to the 9th, 5x, and then the last term would just be a positive 4. Okay. Next term, we got 18, 27, 54. I can take out a 9. Y squared, y to the 5th, y squared. I can take out y squared. X to the 5th. There's only one term with x, so I can't take out any x's. So 9y squared would be my GCF. Dividing each of those terms by 9y squared gives me 2x to the 5th, 3y cubed, and 6. Remember, when you're dividing, you subtract your exponents, you divide your numbers. It might help you to write it down. I don't necessarily need to see you writing it down. It's up to you. Okay. I can't remember if this is part of, oh no, it's not. Okay, here we go. 40n squared plus 20n plus 36. There was a typo. I had too many examples, so I'm just going to quickly go through this. That would be 10n squared, 5n, 9. Number 2 can go 2 different ways. You can take out a positive, you can take out a negative. In this case, we're going to take out a positive 6n cubed, which would give me, when I divide all those terms out like that. You could also go negative on it and have negative 6n cubed here, and then have a positive here, positive here, positive here, and a negative here. Both would be equivalent. Okay. All right, go ahead and do the practice quick checks. Pause the video, try those examples. Number 1 is usually what students screw up. Remember, you always divide out by 6a squared. So 6a squared divided by 6a would be a 1. You do need that 1 in there because if it's not, it is incorrect. Number 2, taking out a 3x squared y squared, dividing each of those out would look like that. Now, if you did do the negative, there's the negative case, and then that would be your answer in between. Both of those are exact same answer. You don't need both, you just need one. All right, difference of perfect squares. Difference of perfect squares. It has to be a difference and it has to be a perfect square. Okay, they have to have 2 terms, both perfect squares. Here we go. So x squared minus 9, you can set it up. 2 terms. Is it a difference? Yes. Are they perfect squares? Yes. So we factor it to be 2 binomials, a plus and a minus. Square root of x squared is x. The only way to get x squared in that first quantity is to have x and x. The only way to have 9 here is to multiply the square root of 9, which is 3. So 3 times 3. Don't switch the order. In this case, 4 minus x squared, that is a difference of perfect squares, a plus minus. Square root of 4 is 2. Square root of x squared is x. Okay. 4x squared minus 25 again. What is the square root of 4x squared? That's 2x. The way to get 4x squared is to do 2x times 2x. 25, 5 and 5. 16 minus 81x squared. So you end up with 4 in the first quantity, 9x in the second quantity. Okay. Even if they go fraction on you, don't freak out about it. Difference perfect square, yes. Take it numerator denominator. Square root of 1 is 1. Square root of 4 is 2. 1 over 2. Second one, square root of 25 is 5. Square root of x squared is x. Square root of 9 is 3. Boom, a plus and a minus. Again, you can have the minus and then the plus, whatever works for you. Oh, that looks intimidating. Take it one step at a time. Square root of 4 is 2. Square root of 81 is 9. X squared is x, so 2/9 x. Square root of 49 is 7. Square root of 9 is 3. 36 x squared minus 49 y squared. Here we go. Okay, we got 6x, 6x, 7y, 7y. Okay. Few more. These have any even exponent. I repeat, any even exponent is a perfect square. Any even exponent is a perfect square. You just got to divide your exponent by 2. So square root of 64 is 8. Square root, of 25 r to the 4th. Think about it. What times what will get you 25? 5. What times what will get you r to the 4th? When we're multiplying, we add our exponents. So that means we got to divide it by 2. Right? Because 2 plus 2 would get that r to the 4th. Okay, square root of 144, b to the 4th would be 12b squared. 12b squared. Square root of 49 would be 7 and 7. 6, even number. It is a perfect square. We just got to divide our exponent by 3. 30, square root of 36 is 6. Square, b to the 6 is 3. Square root of 121 is 11. Boom. 1 minus 144k squared, k to the 6. That is a perfect square. We would have factored that to be 1 plus 12k cubed, 1 minus 12k cubed. All right, go ahead and try this. Okay. Here are your answers. If you did it correctly, let me move that out of the way. Again, pause the screen. Those are just straightforward difference of perfect squares. Okay, one more step to this. What happens if when you first look at it, it is not a difference of perfect square, but it is? Anyway, okay, look at the next one. We got 5x squared minus 20. Is there something I can GCF out of there? Yeah, I can take out a 5. Oh my goodness, guys, look what happens when I GCF out of 5. I've got a difference of perfect squares. So all I gotta do is bring down that 5 and then do your 2 parentheses 1 plus 1 minus x plus 2, x minus 2. 40 minus 250 x squared. Boy, that looks like a difference of perfect squares. What do I got to do? Ooh, I got to take out a 10. Oh, look, there it is. It's in disguise. Factor it. You get 2 plus 5x, 2 minus 5x. Okay, go ahead, practice. Pause the video, try this. All right, you would end up taking out a 7, you'd be left with that. Take out a 3x, you'd be left with that. Factor by grouping. Other than that, that's the lesson for LT1 of this chapter. I know it was pretty quick, but again, this is all review from Algebra 1. Hope you have a great day. Miss Heart out. Woo!